Okay, good morning. So let us continue our detour to Euclidean geometry, our expedition towards Euclidean geometry, and see how it is going there. So do you remember we talked about something we called a Sevian line? So we learned that if I have a triangle, ABC, if I take one of the corners, say A, and take one random point on the opposite side, for example, X on side BC, when I connect this to that, it's called a Sevian line, yes? It's called a Sevian, yes? And then we learn that, of course, a median or an angle bisector or an altitude are particular cases of Sevian lines for a triangle, yes? And there was probably a natural question is it possible to calculate the length of famous Sevian lines for a triangle using the length of sides or not? Yes, do you remember that was the question we asked ourselves? Towards that, if you remember, we proved a theorem called Stewart's theorem. This is what we learned. So we learned that if I call the length of this Sevian line, I don't know the pronunciation, it probably is Sevian line. If I call this length x, if I call this length m, n, and this is as usual c and b. Do you remember what was Stewart's theorem formula? But you have your notes, yes? So if I made a mistake, please let me know. So we calculate, I think, mb squared plus nc squared is equal to length a, the whole length, and then x squared plus mn. That is what I remember, yes? Is that right? Yes. And then using that, we were able to calculate the size of each median, yes? For example, we learned that the median, if this Sevian line is a median, then this becomes 1 over 2 square root of 2b squared plus ac squared minus a squared. And then we have similar formulas for m sub b and m sub c, very similar. So we were able to calculate this. And then we also calculated, do you remember what is the symbol? This symbol is standing for dA. This is the length of the angle bisector of A. Do you remember these things more or less? Yes? Of course, the formulas might be you haven't remembered, but that's not a big deal, so I will write them here. That was the formula we got, and if someone asks you what is P here, what was P, do you remember? It was a little bit a strange convention. So because my goal, yes?
P is half of the
circumference, yes? So P, so in principle, A plus B plus C divided by 2 is what we call P. And the reason is probably only beauty, yes? Assume that because usually P stands for perimeter or circumference, and then A plus B plus C is the perimeter, so why we should divide it by 2 and call it the perimeter. If we didn't do that, then what happens? Then the formula would be similar to this. The formula would be this. Instead of P, you would have 2P. Yes, no, I will have P over 2 then, and then I will have P over 2 minus A. So if I have defined P, in this way, then I need to divide by 2 here. And I hope that you agree this is more beautiful. This one is more beautiful than this one. So probably the only reason behind that is beauty, yes. Of course, there is also good side about this because these 2 will be multiplied by 2, it gives me a 4, and this will be cancelled out. That's good point about this. But then this would be 2a. I don't know which one do you prefer from artistic point of view. Do you think this is more beautiful or that one? Anyway, the next reason will come later. Okay, so I don't know. Probably my eyes have actually got used to this, but I think this is more ugly than that one. Anyway, so So the reason, so remember, in any geometric book, geometry books, you will see P is A plus B plus C divided by 2. Okay, now my question for you is, what is the natural question coming after that? What do you think I will teach you now? Don't you have any curiosity about something here? You should have been waiting for this for 1 week now. Yes, please.
Maybe how x, like the line, the Sevian line is connected to the circumference of the triangle.
No, this we actually answered with Stewart's formula. Using the formula, we were able to find 2 types of famous Sevian lines for, I need to check, is it Sevian line? Sevian line is probably the correct word. Sevian line for the triangle. So, median, angle bisector. The natural question is that how can I calculate the height? Yes? So probably I want to teach you this. I want to find a formula so that you can express, for example, h sub a in terms of a, b, and c. So if I give you the length of sides of a triangle, how do you think we can calculate this? If I have a random triangle, an scalene triangle, whatever it is, and then I have this C, this B, and then I want to calculate the length of this height, which is the height corresponding to this side, so we denote it simply by h sub a. Okay, let me review a little bit. So do you remember what is the fundamental rule behind proving? These are the things that I expect you to remember, not the details. Details is up to you, of course. But do you remember what was the basic rule that I used to prove this, Stewart's theorem? Because some theorems in mathematics are more famous than the others. Yes? Yes? Cosine rule. So the cosine rule was behind the proof of this Stewart's theorem. Yes? And then do you remember, did I use anything for calculate? How did I calculate this MA? Do you remember? I said to myself that if this one is the median, then M and N are equal, and they are equal to the half of BC, and put the numbers here, and I was able to find that X, which in this case is M sub A. Yes? But for the angle bisector, it was not that straightforward, both from algebraic point of view that we had to calculate a lot more, and then we also needed a supplementary theorem. Do you remember what that theorem was? Because that's also a famous and important theorem to remember. It was in Math 2C. Do you remember? If I have a triangle ABC, and if I have this angle bisector, which divides this angle into 2 equal pieces, then if this is M, this is N, and this is C, and this is B, if these 2 angles are the same, then we had a theorem in Math 2C which claims that M over N is equal to C over B. Something like that. So to this one and this one together gave rise to this formula. I think the hardest one is to calculate the height. Let us do it together, okay? So what do you think? Can I also use the Stewart's theorem to calculate h sub a? In principle, I should be able to do that, yes? So if you see, if I compare this one with that one, h sub a is playing the role of x, c is just c, b is just b, but this time m is this one, and n is this one. Yes? And my goal is to calculate the h of a. So I write the Stewart's theorem again. So it becomes mv squared plus nc squared is equal to the length a multiplied by ha squared plus mn. Yes, is that understandable? So the goal is to write a formula which expresses the height h sub a in terms of the length a, b, and c, the sides of the triangle. Okay, so I want to hear from you. What would be your strategy? So by looking at this equation, you see that there are two things I want to get rid of. What are those things? Because you know the strategy is to find a formula for the height in terms of A, B, and C, the lengths of the sides, yes?
So you want to get rid of M and N?
N in favor of A, B, and C,
yeah.
if I can do that. Okay, now I'm waiting for you. Do you think you have any suggestion for me?
Kanske ta du vet också att det är
Nej.
vi liker kolgång.
Det är ganska sant. Roten ur B2 minus HA2.
Ja.
Yeah, let us try something. I had something in mind that it works, but I want to try another idea after listening to yours, if you have any ideas.
The Pythagorean theorem?
Yeah, I was thinking also about that, and that is not a bad thing because it relates N to B and H sub A. H sub A is also good because we need it in the problem. That was missing from my point of view first. But the bad point about Pythagoras theorem is one thing that I want to avoid, but I will test your idea. It's good to explore what will happen. What do you think, what would be the downside of this? Algebraically, there is a downside to Pythagoras theorem here, from algebraic point of view, practical point of view, yes? It's,
The third side.
yeah, that's a big problem, yes? Let us see how it goes. Do you want to explore it? But let us do that, okay? Because even if it fails, you'll learn that mathematics is most of the time failing than succeeding, okay? So, but this is a reasonable strategy. Because you are telling to, so I want to have this unfortunate m. If it was m squared, it was very good, but m, that's a problem. So I have to write m squared is c squared minus h squared, h sub a squared. Everyone agrees with that. And then I can write similarly in this next triangle that n squared is what? B squared minus h sub a squared. And the point is that, unfortunately, when I want to plug them here, I have to take the square root sign. So this becomes the square root of c squared minus ha squared. And then what happens? Times b squared. So let me write b squared on this side. And then I will have c squared square root of b squared minus ha squared. Yes? Agree with me? That is done. On the right hand side is a, and I have ha squared. Then I will have m times n, which is even more awful, yes? So then it becomes c squared minus ha squared multiplied by b squared minus ha squared. So you see, in principle the problem is solved. Yes, this is in principle, because what I have just h sub a, which is my unknown, and what is left for me is what I need. So in principle, you really don't need to find a formula if you are not very interested in algebra. Whenever I give you b and c and a, you can plug it in this formula and solve the problem numerically for those particular values of a, b, and c. But because we are very, very curious in algebra, we don't like this. We want to find h sub a as a formula. By the way, this is not a very useful one. If you want to use the computer, if you want to write a code to calculate h of a, whenever you give a, b, c as input to the code, this is useless unless your computer program knows how to solve that problem, yes? Otherwise it is useless. But do you think there is a hope that we can get rid of somehow? We should be able to solve that problem somehow? Because the point is really, really serious. You have to square it, yes? With the hope that you can get rid of h sub a out. So even though that is also a very good thing to learn. So the strategy was completely correct. And we actually succeeded that. The problem is practical things that is actually making an obstacle for us. So we need to find probably a different way. Or if you're so stubborn you want to continue, you can continue, be my guest, yes. But I think might be you are also finding a different way for that, I don't know. Yes. In principle, this should be doable, but I don't see any way out of it right now. Might be I can think a little bit about it. But there is another way that I was thinking, and it definitely works. I'm not saying it works easily, but at least algebra goes fine. Yeah, I really hate surds, you know. Working with them is not that easy. And that is again using the cosine rule. So can you tell me, what can I write for m in terms of cosine of this angle? This is simple, yes? Do you write, if I write this, do you agree with me that C times cosine B is okay for m? Yes? But you might say this is also useless because I am bringing something new in the problem, yes? I didn't have any angles involved. Now I am involving myself with angles as well. But angles, no problem, especially cosine. Do you say what? Do you know why? For example, can you write me a cosine rule which involves cosine of B? Write a cosine rule for me so that involves cosine of B. You know that we have 3 cosine rules. One for cosine A, one for cosine B, and one cosine C. We want to write one which cosine B involved. So I have to start with B squared is equal to what? A squared plus C squared minus 2AC times cosine B. Do you agree with me? This is one of the formulas in cosine, and it already tells me what can I write for this part. Because this is eliminated in favor of the things that I need without any square root signs. Yes, that's a success. Yes, so I move this to the right, to the left, it becomes positive, and I move this one to the right, it becomes A squared plus C squared minus B squared, but what I need is this part. So C cosine B is nothing except this. Do you agree with me? So this is better. I'm not saying this is easy, but at least I do not have any surd signs involved. So if I plug this back here, this is my m. So m is equal to a squared plus c squared minus b squared divided by 2a. So wasn't it simple? So of course it is not as efficient as before, apparently, but here the downside is that I have to face with m squared, but with this trick I am just working with m itself, and what I need, fortunately I need m, not m squared. So even though this method was strategically correct, but I will ignore that because it was technically difficult. Yes? Is that understandable? Now, I don't think you need for me to calculate this. Can you guess what would be the correct formula for n? There is no difference. The only difference is that B has replaced for C, yes? That's the same strategy if I solve the problem here. So can you tell me what would be the formula? What would be the denominator for n? What is your guess? The denominator should be? The denominator should be? So you in your head assume that you are solving this problem, but the name of C has been replaced by B. That's the same story, yes? So what happens for the denominator? Nothing probably will happen. That would be the same thing. But for the numerator, what will happen? Wherever I have C, I have B. Wherever I have B, I have C. Yes? So what happens? A squared is the same thing, but this becomes plus C squared plus B squared minus C squared. Agree with me? If you don't believe, you can do it once more for yourself. So now we are actually done. Now interesting algebra starts. Yes, because we are in principle done. What I have to do, instead of m, I put that expression. So this becomes a squared plus c squared minus b squared divided by 2a. And then I multiply it by b squared. Oh, this is also horrible, yes? And then anyway, but this, because this becomes the fourth degree, but let us see what can we do here. So then it becomes a squared plus b squared minus c squared divided by 2a, and then multiplied by c squared. And please check my calculations, okay? Okay, it's very, very hard now. Because I have to multiply those. This is ha squared, and then I have to multiply this by that, which gives me 4a squared here, and then I have to multiply these two, yes. But let us do this fun algebra, because it gives rise to a formula which is very, very famous in mathematics, and it's called Heron's formula. Yes. If Heron could do it, I don't know, sometime BC, probably we should also be able to do it, yes. Hopefully. Okay, but I hope that you agree this, even though this is also not easy, but easier than the other one. Because here I have to square it. This one is squared, 2 times the first one times the second one. Again, a third will survive. And here will also the same thing, yes? So it is probably not hopeful. But now I want to manipulate this as much as possible, and I want to get h of a. By the way, it's already solved. Why is that? Because you multiply this, even though that's a big thing, don't worry, you just take it to the left and then divide by a. That's your answer. So we actually finalized the problem, but this is ugly. We want to spend some energy to make it more beautiful. Is that clear? So let us just do it exactly as what I mentioned. So, but let us do it more effectively. What is your guess to do it more effectively? So if you don't mind, let me multiply this a inside. This a will be multiplied here. It becomes ah squared. And that a that I am multiplying here will cancel one of these a's. Agree? So, okay, that's better. Yes? Now I move this to the left. Okay, I don't like fractions, so let us stick to my rule that I hate fractions. So let us get rid of fractions first. So I want to get rid of 2a, 2a, and 4a. So I multiply everything by 4a. Yes, if you don't mind, so let me just multiply everything by 4a. What happens? I will get a factor of 2. A factor of 2. 4a will be gone. This will be 4a squared. Yes? Are you comfortable if I just like that? So 4a, this is gone. I have a factor of 2. And then this is also gone. I have a factor. Please check my calculations. I have a factor of 2. This becomes 4a squared, and this is totally gone. Yes? Yeah, you see, it is manageable now. So I move that to the left. So what happens? So let me write this one first. 4a squared ha squared is equal to this expression. I think it's inevitable. We have to multiply things. So let us just do the boring thing right now. So this becomes 2a squared b squared. I'm multiplying these things inside. 2c squared b squared, and then I have minus 2b to the 4, and I will do the same thing here. So it becomes 2a squared c squared plus 2b squared c squared minus 2c4. Yes? And then I move this to the left. Let us just do it in our head. Yeah, by the way, do you feel this is a conjugate pattern or not?
I wanted it to be, but I don't think it is.
No, but you can make it a conjugate pattern. It is not a conjugate pattern like this, but you can force it to be a conjugate pattern by, for example, keeping this, I would write it as a squared. I factor a minus sign out. Yes, do you agree? Minus b squared, positive c squared. So what I have written on top is exactly this expression. Yes? And then now you can see that I can put a pair of brackets around that, then you can see your conjugate pattern appears. Yes? Yes or no? Mm-hmm. So this becomes the first one to the 2, which is a to the 4, but I'm supposed to move it to the right. It becomes minus a to the 4. Yes? Is that right? And then this one to the power of 2, minus b squared minus c squared to the power of 2, move it to the right, it becomes positive. Yes? So you can do a lot of things in your head, especially if this is long. I will really be lazy to write it down. But hopefully, if you don't understand, I can write it. Is that understandable? Okay. Now, the only thing that we can do is to simplify this nasty looking thing, yes? Do you have any suggestions for me? At this level, you have a lot of experience in mathematics, by the way. If you want to simplify, what is your starting point? Just say it. What's the starting point?
You add the similar terms.
There are no similar terms, are there?
B, C, C.
Yes, there are.
C squared.
Yes.
C
So let us not write it. So I would write it 4. I will clean it. Agree?
Yeah.
Yeah, that's good. One step forward. Then, what is the only thing that you think is reasonable to do here? Just say it. It's clear.
Get rid of the parentheses.
Yes, we don't know what's going to happen. You don't need to predict. You don't have to predict everything until the end of the problem, yes? But you are simplifying, so the first thing that I can do, I just get rid of this one. Let us do it in our head, yes? So, this becomes b to the 4, positive. But I have minus 2b4, so this is gone. Yes or no?
Yes.
And then I have positive c squared, c to the 4. I have negative of them, so this is also gone. Yes? And then I have 2 times the first one times the second one, minus 2b squared c squared. So this becomes back 2. And then I got rid of this. Yes? Understandable? Yes or no? You can just expand and simplify. But the problem starts from here now. What can I do with this ugly thing now? It turns out that it is really interesting what can happen here. So let me just see if I can do it myself first. So 4a squared, let me organize it. 4a squared h squared. Unfortunately, I don't like to have these negative signs for these even powers. So if you are with me in that, let me take a negative sign out. Yes, do you agree? So then it becomes positive a to the 4, positive b to the 4, positive c to the 4. And every other term becomes negative. Minus 2a squared b squared, minus 2b squared c squared, minus 2c squared a squared. Yes? So that would be this one. The reason, I don't know. This is my habit. I want to always make these things positive, yes, when I have even powers. It doesn't have to. But then, of course, I want to give you, I don't know how much you know about identities. Yes, but I want to give you some identity here. So let me just discover this. Let me just write capital letters, A, B, and C. I want to square it to power 2. So let us see what happens. Then it is not solved. The problem is the signs. We have to adjust the signs, unfortunately. So this becomes, it means that I can write it as A plus B plus C to the power of 2. Then this becomes the first one to the 2 plus the 2 times the first one times the second one plus the second one to the 2, yes? And then I expand this one, it becomes a squared plus 2ab plus b squared. And then I multiply these two inside, so 2ac plus 2bc plus c squared. So this means that if I organize it, it becomes this. Yes? So that is also very, very important identity to remember. If you have a trinomial, a polynomial or any expression with 3 terms, if I want to square it, I just did it. It's like mathematics 1c. It is not hard, but probably it's not very famous for your eyes. I'm just trying to make it familiar for you. So I just calculated it and I got this. So this tells me that this is the first one to the 2, the second one to the 2, the third one to the 2, but 2 times the first one times the second one, 2 times the first one times the third one, and 2 times the second one times the third one. It's a little bit extension of the theorem that we have for 2 terms, yes? But the point is that, can I use this here? That's a little bit unfortunate, because I have powers of 4. So do you have any way out of it? I won't have powers of 4, but this theorem tells me powers of 2. Yes?
Yes, the power 2 for every.
Pardon? Yes, so okay. So you are telling me put a power of 2 here, yes? So what will happen? Let me get rid of the first line, because I don't want to write so many things. If I write a squared, b squared, c squared, what will happen here? This becomes 4 this becomes 4, this becomes 4, 2, 2, 2, 2, 2, and 2. Agree? But still, there are many things to do. I have some minus signs. Yes?
You use minus c.
If you want to make this minus c, then this becomes minus, agree, because this is c involved. This also becomes minus, agree. But that's again unfortunate because I also need a minus sign there. Yes?
And then and no. Or you change the last positive to -2. Or does that work?
This one?
Yeah.
Let us. If I change this to negative, then this one multiplied by this one again turns out to be positive. So is the problem clear, or am I going very fast?
No.
Is that understandable for everyone? Yes? Yes? Okay, so if I put this minus sign, two of them becomes negative, good, but unfortunately this becomes positive, but I need negative. If I make this one also negative, 2 times the first one times the second one negative, good. 2 times the first one times the third one negative, good. But 2 times the second one times the third one becomes positive again, not good. Yes? Yes?
Can't you add a minus for AB?
Yeah, that's the trick. So we cannot get rid of that. So we cannot fix everything as we desire, but we can still do some amend. Yes. So what can I do here? Exactly that what you said. And then something very nice and strange happens. Let us see. So what I do, I would write it as 4a squared. So let me don't write this. I just follow. It becomes equal to minus a to the 4 plus b to the 4 plus c to the 4. So which one is good for us? This one is good. So I want to have these two negatives. So let me, instead of this one, I want positive, yes? But I have negative. What I do, I write positive because I need it. And then copy paste the left. But I have to compensate for this change. How? By subtracting this. Yes? Agree? So what I have done, I convinced myself that I will not be able to make all the signs right. But I can make 2 of the signs right. One sign will remain. I need the positive one to make it like this. So what I do, I write the positive one and I subtract 4a squared b squared out of it. It is not clear it's going to work. Who knows? But Heron probably was lucky and stubborn, it worked for a nice formula. So you need to do some trial and error. But now can you tell me what can I write about this package? What can I write? Exactly the same thing here, yes? So I can write, so this becomes equal, so let me clean this. It becomes equal to minus a squared minus b squared minus c squared squared, and then minus 4a squared b squared. Yes? Let me just try it again. If you don't believe, do you remember the formula? The first one to the 2 plus the second one to the 2 plus the third one to the 2 gives me these 3 terms. 2 times the first one times the second one. Oops. No, this is positive. This is positive. 2 times the first one times the second one gives me this. 2 times the first one times the third one gives me this. And 2 times the middle one times the third one gives me this. Yes? And then I have an extra term at the end. Is that understandable? Yes or no? Okay, then what? By the way, let us get rid of this minus sign. It becomes positive 4b squared minus this one. Yes, so far so good. But do you think it's also beautiful? First of all, it's more beautiful than the previous one. So even if I stop here, we haven't lost that many things. So what I need to do, I need to divide by 4a squared. And the good point is that this will be gone, and then I will have it. So that's a reasonable formula. But if still you are seeking for beauty, you need to go further, yes?
Conjugate pattern?
It's a conjugate pattern now, yes? Because we can factorize it using the conjugate pattern, yes? So it becomes 2ab minus a squared plus b squared minus c squared times 2ab plus a squared plus b squared minus c squared. So tell me that you understand what's going on. Is that understandable for everyone? Yes or no?
Yes.
Everyone, I have this pattern, the difference of 2 complete squares, so that is the conjugate pattern. Now you see something beautiful now happens. What is that? It depends what you call beautiful, but this is beautiful, yes?
Now you can take this. Never mind.
Yes, yes. We can create another conjugate pattern in each pair. Yes. So how? I can just let us just do something in our head again. This one and this one and this one can be combined back to this form. It seems that we are crazy. We are opening, closing, yes. But something nice will happen, yes. We are opening the box and we are closing it. So do you agree that I could write it like that? A squared, b squared, 2 times ab, and minus c squared. That's exactly the same expression. And let me just do this. This is a little bit different. What is that one? I multiply this minus sign inside in my head, so it becomes c squared. And then I factor a minus sign out, and I will write it a minus b squared. Yes? Let us check. C squared is the correct one, because minus minus c squared. A to the power of 2 is a squared. A minus sign comes from here. It makes it minus a squared, right? B squared, minus sign comes here. It becomes minus, right? Minus 2 times AB, minus becomes positive. So what I have written is correct. Yes or no?
Yes.
I'm just doing the algebra faster. You can just do it. This is not very hard. But again, you see the conjugate pattern appears. Okay? Again, we have to open the box again. So it becomes C. Can you do minus this package, which is minus A plus B, C plus this package? Agree? And then I will do the same thing here. A plus B minus C, A plus B plus C. Yes, finally we factorized everything. Yeah, take your time. Do you want me to explain it again? So I am taking, so for example, C minus A minus B times C plus A minus B. But minus A plus B, this is what I have written here. And then C plus A minus B is what I have written there. And the same story for that. Okay, now can you see what happens? This has a good name in geometry. What's the name?
2p.
Is 2p, yes? Yes? And what is the name of this guy in geometry? There is no name, you need to make a name for it. What is that? If that guy is 2p, what is this guy? 2p minus 2c. So whenever symmetry comes in, mathematicians become excited. So what's the name of this guy now?
2p minus 2.
2p minus 2b, yes. And then probably you can guess what's happening. That's the beauty. What is this one?
2p minus 2.
2a. Agree? Yeah. Then what can I do? I can factor a 2 from every of them. So a 2, 2, 2, 2, it becomes 16. And I have a very nice formula. 16, I write p, and then p minus a, p minus b, p minus c. It's easy to remember. Yes? It's this one. And then I want to calculate h sub a. So what I do, I will actually, this is HA squared. So HA squared is this expression that I got divided by 4A squared. Yes? Because what I calculated was the right hand side, which is this expression. But I want to calculate this. So I divide this expression by 4A squared. 16 divided by 4, it becomes 4. And then I have A squared here. Am I right? Yes. And then I have P, P minus A, P minus B, P minus C. Agree with me? And then finally I found my HA. So HA is 2 over A, P, P minus A, P minus B, P minus C. So this is your formula and now you are very happy, yes? So this is easy to remember, yes?
I just have a question.
Yes, please.
I don't really understand the step. The last one there. How did you just...
This one?
Yeah, I understand why you put minus 4a2, b2, but...
Okay, so what I motivated you why I did this because I want to have a positive sign.
Yeah, I understand why, but I don't understand how.
Okay, but now let us go here back. What I can tell you is that be patient and expand this expression. You will get what I have underlined here.
Yeah.
Let us check. Do you remember that formula for trinomials? The first one to the 2 gives me a to the 4. The second 1 to the 2 gives me b to the 4. The third 1 to the 2 gives me this one. 2 times the first one times the second one gives me this. 2 times the first one times the third one, because this is negative, it gives me negative 2c squared a squared. Yes?
Yeah.
And 2 times the second one by the third one will give me exactly this one.
But I mean, how is the equality the same if you
Oh, they are the same because here I had a minus sign, but here I have written plus 2 minus 4.
Yeah.
So that was the trick. Because if you remember, I couldn't fix the signs, all of them, so I have to use this trick. It might happen that this trick will not work, but we don't lose anything. We don't have a beautiful formula. Yes, but we have a formula. But now it worked, we have a nice formula. So that is your formula. But this is not called the Heron's formula, because Heron was actually, it's probably caring about beauty more. He was calculating the area. And the area is really nice formula. So by the way, this is HA squared, sorry. So I made a terrible mistake. So this is 4 still. This is a squared. So if I want to find HA, I have to take a square root sign. It becomes 2. It becomes a, but this also becomes this expression. Yeah, that was the correct formula. So, because I was careless, I have to take the square root of everything.
Don't fall into the trap.
Yeah. And then what happens? We calculate now the area that we are working very hard. First of all, this is your formula. It's giving you the last Sevian line in terms of A, B, and C. And then, of course, if I ask you what is the area, area is denoted by S, probably surface or whatever. In geometry book, it is a standard. So S is equal to, do you remember what is the formula? If I write this, do you agree with me? This is one of the formulas for the area. 1/2 of the base multiplied by the height. Yes, that's the formula. But now, the nice thing is that this A over 2, when I multiply it by this, will cancel that one as well, and I have a very nice package of beautiful formula. And this is very, very famous. So Heron's formula. By the way, this is actually very, very handy in those days. Assume that you have a piece of land, and that is in the form of a triangle. This formula is more or less useless. Do you agree? Because if you want to calculate the area using the standard formula, what you have to do, of course you can measure the base, that is no problem, but then you have to measure the height. That is practically hard, because you need to go to the corner and try to make sure that the line that you are drawing is perpendicular. If you have a very big size land, it is not that easy. But Heron's formula doesn't care about the height at all. It cares about the size of sides, and then you can measure them and put them in that formula and find your S. Probably that was the practical reason who motivated Heron to actually invent this formula. So that's one of the most famous formulas, and I think it was a pity if you leave high school and haven't seen that. Okay, so you see that you know a lot mathematics. You see, you can do a lot of things with your own knowledge. The problem is that you need to find the correct strategy and train yourself to understand how it goes. Okay, so what we have shown, so let me write this list here a little bit. Now I want to ask you some deeper questions. These are not calculation. This is not from calculation point of view. This is just from conceptual point of view. Okay. So do you remember, I wrote a formula for the size of the angle bisector. Okay? Now assume that in the first session I ask you, okay, students, please prove this one for me. Okay. Okay, if you go back to your notes, do you think this formula is correct according to your notes or not? If you don't remember, you can just see your notes. If I ask you to prove this, Of course, you know the correct answer. Go back and check your notes. Is this the correct formula?
No.
No. What is the correct formula?
You take away the A and B. It's only P in parentheses P minus A.
So here, so what is the formula? It's
Uh,
square root of?
P in parentheses P minus A.
There is no BC or whatever here.
Not what I wrote.
So might be I wrote something wrong in the beginning, yes? Didn't I write something wrong when I started?
I thought it was BC.
Yeah, it is BC, yes?
Yeah.
So I think that's correct. So what I wrote is correct. But now assume that I ask you to prove this. Yes? Yes?
No, it's BC, not W.
Yes, I know. Yes, you by now you know the correct formula and you can judge this is not the correct one. But even without one single calculation, you could realize this formula is wrong. Why is that? If I ask you to prove this formula, if you are smart enough, you raise your hand, you say that this is impossible to prove. Do you understand what I mean? Now you have the correct formula in front of your eyes. You compare them and say that, Bobak, this is wrong. But assume that you didn't have the correct formula in front of you, and I ask you to prove this. It should be, if you are smart enough, you can immediately tell me this formula cannot work. Why is that? First of all, tell me, is the question clear? How, without doing any kinds of calculations, you can tell to the teacher, this is impossible. That, after all those calculations, I get this formula. It's not possible. This is a deep question. The previous questions are technical questions. You need to do algebra. But this is a deeper question. Exactly, I really want you to understand, even in physics it's very important. You calculate something in physics, and then you get some number or a formula. You need to have a good evaluation and judgment about does the formula make sense at all or not. Because if you learn these things, you can detect your mistakes. So for example, if I calculated something wrong, I would wonder that, oh, the formula is not what I expected. Why? Answering this is deep, yes.
Is it because of the cosine rule?
No. I don't know, but probably much simpler than that. I want you to tell me something about a word. I want to refer me to a word why this cannot work. I can also guide you about the word. The word is symmetry. No? How symmetry argument is related to this understanding immediately that this formula is a wrong formula. Let me ask you something. What did I do? My goal is to calculate the length. So here, let me write everything simple for you. So I have this triangle. Yes, this triangle, and then I have the angle bisector here. This is DA, and this is ABC, and this is little c, this is little b, and I am supposed to calculate this. And then of course you know that this length is A. I am claiming that this formula cannot be the correct formula for this. Why is that? Because of symmetry arguments. What do I mean by symmetry arguments? By symmetry arguments means that try to imagine a triangle where the role of B and C are interchanged. Okay, what do I mean by that? So what I mean is that let me try, of course I do not have enough tools in my hand, but let me assume that, yeah, for example, this one, and then I want to draw something like that. I want to keep it as before, and I want to do it here. Okay, now let me draw the angle bisector of this one. So this one, I want to make this one C, this one B. Okay, and this one, do you think the sizes of these two will be different or the same?
The same.
It would be the same, yes? Agree with me? Because these two triangles are congruent. Because this side is equal to that side, this side is equal to this side, and that side is common between them. So they are congruent. So the DA and this line and that line are having the same sizes. So it means that the formula that I get should be invariant under this symmetry change, under the interchange of B to C, C to B. Yes? But this is not it. If I change B to C, C to B, this part will not change. This part will not change, but this part will change. It becomes AC, which is not equal to AB. But what was the real formula? The real formula was this. And now you see that this is symmetric. If I change B to C, C to B, the formula is the same. Is that understandable? It was not this. It is a very deep consequence of symmetry. Symmetry arguments are very extremely important in mathematics and physics. So if you know that your problem enjoys some symmetry, geometrically, that symmetry should be transparent in algebra itself. Is that understandable? So if you have a symmetry from geometrical point of view, you should be able to detect that symmetry in equations. And that equation is coming. It's a very, very deep concept. Is that understandable for everyone? Do you understand my argument? So you see that by interchanging the role of B and C, I have another triangle. But immediately I could convince myself that this length remains the same. This is called invariant. So the length of the angle bisector remains invariant under the interchange of B to C, C to B. So this geometric property should reveal itself somehow in my algebra calculation. And by the way, do you think that this also should be the case for median? Do you think that I can use the symmetry argument in the median as well? And now you see that median formula was this. Do you remember in algebra? Do you see the symmetry going on between interchange of A and B and C? You see the formula. So if I write this formula for you, you immediately detect that this is wrong. So if I ask you to prove this, you immediately say, no, this is not possible. Why is that? Because if I change A, B to C, C to B, this formula would be different, but this formula will be the same. So if I ask you, by the way, if I give you a question with 4 options, and I ask you which formula is the formula for the median, and I give this one, and I give you this one, you immediately realize, even I don't remember, but that should be the correct formula. So that is the strong point about symmetry arguments. You really don't need to calculate anything. Is that understandable? If not, please ask me, because that's a very deep concept. Is that understandable? Okay. So now we have a lot of nice and fun formulas in our hand, and then we want to continue to something very interesting. In the next quiz, you will see a word locus. I don't know how many of you have seen that word in the second quiz. But I want to describe that one because the due date is the 10th of October, so we have enough time. So I want to talk about this locus, which is actually, the plural form is loci. In Persian, if I want to translate it literally, it's called geometric location, and I think it's a very nice word because it's more illuminating than locus. Probably locus is a Latin word or something. But what do we mean by a locus? Okay, so it's extremely important. And by the way, one of these questions you got in the exam competition. So one of them you were able to solve it using these ideas. So this locus means, how should I define that? It might be by example is better. So the locus means a set of points sharing a common property. Okay, locus means a set of points, okay, that all of them share a common geometrical property. Okay? Is that understandable? For example, the circle is a locus. But how can I say the locus? Why? Because if I draw a circle for you, it's a locus. Why? Because all the points on this object share a common property. They share a property. They share a property in common. Yes, how do you say it in English? Is that right? Yes, you share a property. They share a property in common. So what is that property? So this point is on the circle. This point is on the circle. Of course, the distances from the ceiling to the floor might be different, so that's not the property. But this point, that point, that point, that point, every other point share one common property. What's that? Yes?
It's the same distance from the middle.
Mid. So what I say, I would say that the locus of points, so I want you to learn this terminology, the locus of points M that are equidistant from a point, from a fixed point. Sorry, let me make it more clear. The locus of points M in plane that are equidistant from a fixed point is a circle, is the circle, is the circle centered at the fixed point whose radius is, how should I say it in this sentence now? Can you help me? The locus of points M in plane that are equidistant from a fixed point is the circle centered at the fixed point whose radius is equal to that distance, but yeah, is equal. Yeah, let me just, you understand what I mean, just let me keep it here. I don't know how to finalize the sentence because I should have mentioned, I will complete it later, but I want you to understand, so is that understandable now? So I would say the locus of points M in the plane or plane, because we don't know which plane we are talking, in a plane, so the locus of points in the locus of points M in a plane that are of distance R from a fixed point is the circle centered at the fixed point of radius R. I just want to have a prototype sentence for you to understand how you use this word locus. Is that understandable? Yes?
So it works for a sphere as well.
Yes, that was my next question. Now, if I ask you I want you to understand this terminology. I can ask you in the exam, for example, what is the locus of points M in a space that are equidistant from a fixed point? What is that? Let me repeat the question. What is the locus of points in a space, not in plane, that are equidistant from a fixed point? What is that? Just give me the shape. What that shape is? It's a sphere. Is that understandable? Yes? Okay. So this is the meaning of how to use the word locus. Okay, can you tell me this one? I give you two fixed points. This I want you to improve your intuition. On the whiteboard, I just fixed 2 points for you. I am not allowed to change the location of these 2 points anymore. And I want to stick to the whiteboard. I do not want to come into space. I'm living on the whiteboard now. I'm flat, okay? So now, what can I do here? I'm asking you, what is the locus of points M that are equidistant from A and B?
The middle.
Middle is correct, but by the way, this is extremely important. What you said is the middle point is not wrong, but is not the whole story. Yes?
The thing is, okay, so you can draw two circles around A and B, and when the places they intersect is the same distance from both of them, and at that point you can draw another circle and call that the locus.
No. You started very good. So Ulle actually detected one of the points. You are detecting two of them. So you are telling me that I draw a circle, for example, here, and the circle here should be of the same size.
Yeah.
Otherwise, you lose the symmetry. If I do it, and then you say this one point and that one point is also belonging to the locus. Yes, that's correct. Because this one to this one is the radius of this circle.
Yeah.
If I haven't changed the circle, if I haven't changed the opening of the compass, and I have used the same compass with the same measure to draw this one and that one are the same. So
Yeah,
this
yes,
point
yeah.
and that point are points on the locus, that is for sure. What Ulle said that this point in the middle is also one of those points. But are these the only points? Or, by the way, when I ask about this locus point, I am not asking you to give me some points which work. I am asking for all of them. So where are all of them? Yes?
I don't know if I can express.
Yes?
If you draw a line perpendicular to the line between the line A.
Yeah, exactly.
With equal distance from A.
So that is called perpendicular bisector. Yes?
Perpendicular bisector.
Yes. So that is the word I want you to learn, okay? That is called perpendicular bisector. So, but I want to teach something very extremely important by this simple example. So I am telling you, so your claim is that the locus that I am looking for is to find the perpendicular bisector of this line segment. What is the meaning of that? It means that I find the middle point, and then I draw a perpendicular line here. This is called perpendicular bisector. Okay? You are claiming that the locus is this line. Yes or no? Yes. That is, so this M is in the middle. You change your point of view, yes. But you are telling me that find the middle point, so it means that this size and that size is there. And then I will try to draw a line perpendicular to this line segment. This is not a line segment, this is a whole line going to infinity. So it means that this is called the perpendicular bisector. Now, your claim is that this is the locus I was asking for. Yes? Is that it's reasonable? How should I prove this claim? This is very important. It's very, very simple, but you think that you want to mathematically show that this is the locus. I don't want to give me the details. I want to give me general strategies. Yes? No, don't say me. No, I don't want the details. I want to understand the general strategies.
Because it's always the same distance from A and B if you choose a point on the line perpendicular.
No, probably I couldn't. Yes, that is that the whole story? At least you can answer this question. You are telling me the details of how to prove it. I'm not asking about the details, we can come with that idea, but my question is that what is the general strategy? Do you think this is enough? I take a random point here and I show to you that this distance is equal to this distance. Is that enough?
No.
Do you understand my question? This was suggested by Dennis. We want to show that this is the right one. How should I prove it?
Using x instead of a number.
No. So let me tell you what I mean. I mean this. You need to choose a random point, a representative point on that locus, and show what? Show that that point enjoys the property that you are asking for. It means that I will take a point here, any point, and I show that this one is equal to this one. If I can show this, but is it finished here at this stage, if I can do that? This is my question. Is it finished and you are relieved?
If you prove it, then yes.
No. Even if I prove it, the answer is not finished. The problem is not finished yet. Why?
Because you have to prove that no other
Exactly. That is the point. So that I wanted to teach you this. So if you want to show some locus that you are claiming is the right one, you need to do two things. You need to take a representative of that locus and show that it enjoys the property. This is not enough. You want to show that no other point will enjoy that property. That's important. In other words, you need to show me that if a point enjoys the property, then it is on the locus. So it is a two. So when I ask you to show it's a locus, you yourself need to understand to prove it in two ways. You need to take the locus, pick a point on it, and show that it enjoys the property. Then clean the locus and take a point enjoying the property and show that it is on the locus. Do you understand the logic? Both of them are necessary. You cannot just ignore one of them. Because if I just prove the first part, someone asks you, why do you know that there are no, of course all the points are right, I agree with you, but how do you know that there are no other points? We need to show that no, there are no other points. Is that understandable? That is the meaning of locus. When I ask you about the locus, I am not asking you about finding some points with that property. I'm asking you about all possible points with that property. Okay, now this is a little bit tricky, even though it is very trivial, but let us prove it for this case. And remember this, memorize that. If you want to find the points on the plane which are equidistant from two fixed points, remember the locus is the perpendicular bisector of the line segment. It's really important, write it somewhere. I'm lazy to write it down. But you help me to prove it. So, how should I prove it? We are done or no? Yeah, we can go for 5 minutes, okay? So, what should I do? The first stage, I will take the perpendicular bisector. I take a representative point of my locus, and I want to prove that this point enjoys the property that I mentioned for this. So, can you tell me, so by the way, this is also good to know, if you have an implication, the name of this part is hypothesis, or sometimes they call it premise. And this one is called conclusion. Okay, so these words is good to know. Okay, so let me call this one M. So what is my premise here? Premise, by the way, let me call this D. D is a set of points, so I can use the set theory language. M belongs to D. Yes? M is a point, is a member of this line. M belongs to D. This is my premise. What is my conclusion? Can you tell me? My conclusion is MA is equal to MB. This is question mark. And this is not finished. I need to interchange the role of these two and prove it again. Yes? The next time, my premise would be that MA is equal to MB. I need to show that M belongs to the perpendicular bisector. So is that understandable? If you want to prove this, you have to prove it in two directions. This is a have to. That's implemented in the word locus. And then you need to be careful not to mix things up because they are really trivial sometimes. Okay, so how can I prove this one? Let me call this statement 1, statement 2. So I want to go to statement 1. I know that M belongs to perpendicular bisector. So what I know, do I know that this one is equal to this one? Do you agree?
Yes.
In first part, why? Because I told you that D is perpendicular bisector. Do you agree that this angle and that angle are equal?
Yes.
Because this is perpendicular bisector. And of course you have to agree that this line is in common between them. Yes? So what happens? It means that this triangle and that triangle are congruent based on side, angle, side. If they are congruent, it means that this length is also equal to that length. End of the story. Is that understandable? Now, the picture that you want to draw for the second one is very similar. It's actually the same, but the logic is different. here I do not know that M belongs to the perpendicular bisector. What I know is this. What I know is that M is somewhere so that MA is equal to MB. I know this one is equal to this one this time. Okay, I want to show that M belongs to the perpendicular bisector. How should I show that?
Can you draw the height?
Exactly. So here you have to draw it manually, and so you draw something. You draw this height. But what I should show, I need to show that this M belongs to the perpendicular bisector. I know that M belongs to this line. I did it myself. I know that this is perpendicular. So what is up to me to show is to show that this is indeed perpendicular bisector, which is bisector, yes. Now the logic is different. You see, this one is equal to that one. This one is common. These are, we don't know they are right angle triangle, or we know, yes we know, they are right angle triangles. So if this one is shared and this one are equal, what can I conclude using Pythagoras theorem about these two? This size is this size, this is common, so what will be the next, this one, and they are equal because of Pythagoras theorem. So it means that this one is equal to this one. What does it mean? It means this triangle is congruent to this triangle. So what it means that these two, sorry, we are done actually. So we are done. We wanted to show that they are the same and then they are done. Yes? So it means that, what I want you to learn is this. When I want to talk about locus, every locus problem you have to convince me in two directions. This is extremely important. Of course, I will talk about the locus later next time. I will continue a little bit of the intro to Euclidean geometry, but then I will go back to vectors. Yes? Any questions? Thank you very much.
You know,